There is a device sold in every hardware store and advertised across social media right now that promises to reduce your home electricity consumption by 20 to 40% simply by plugging it into any wall outlet. It is marketed as a power saver, energy optimizer, or electricity stabilizer depending on the brand. The product listing shows dramatic before and after utility bills. Customer testimonials claim savings exceeding $100 monthly. The device itself is a small plastic box, roughly the size of a deck of cards, with 2 or 3 LED lights and a standard electrical plug. It costs between $20 and $60, and it does absolutely nothing to reduce your electricity consumption, not a single watt. The device contains a capacitor, sometimes a small LED circuit board, and occasionally a resistor. These components cannot and do not reduce the amount of electricity your home appliances consume. They cannot slow your meter. They cannot optimize power factor in ways that affect residential billing. They are electronic placebos designed to exploit consumer misunderstanding of how electricity metering works, packaged with fraudulent marketing claims that survive only because regulatory agencies cannot monitor every product flooding online marketplaces. This is the story of energy-saving devices that fail completely, why they continue selling despite universal technical debunking, and how the same pattern repeats across multiple categories of home efficiency gadgets that promise savings they cannot possibly deliver. Right now, search for Power Saver or Electricity Saver on any major online marketplace. You will find dozens of products with identical claims: reduce electric bills by up to 40%, stabilize voltage to protect appliances, extend equipment lifespan, improve power efficiency throughout your home. The marketing language is carefully crafted to sound technical without making specific falsifiable claims that would trigger regulatory action. The products have thousands of reviews, many 5 stars, describing significant savings. But if you examine those reviews critically, patterns emerge. Many describe savings without providing actual data. Others attribute reductions to the device when other factors like weather changes or behavioral modifications better explain the difference. Some are clearly fabricated, posted by seller accounts or incentivized reviewers. Independent electrical engineers who have purchased and tested these devices universally confirm they provide zero measurable reduction in electricity consumption. The capacitors inside can improve power factor slightly, but residential customers are not charged for power factor. Utilities bill based on real power consumed, measured in kilowatt hours. Power factor correction provides no residential billing benefit whatsoever. Let us go back to the fundamental misunderstanding these products exploit. Electricity meters at residential properties measure real power, the actual energy consumed by your appliances, and convert it into work like heat, light, or mechanical motion. This is measured in watts or kilowatts. Your bill reflects kilowatt hours, the total energy used over the billing period. Some electrical loads, particularly motors and transformers, also draw reactive power, which circulates between the device and the grid without performing useful work. Reactive power is measured in volt-amperes reactive. In commercial and industrial settings, utilities charge separately for reactive power because it stresses transmission infrastructure without generating revenue proportional to that stress. Large facilities install capacitor banks to correct power factor, reducing reactive power draw and lowering demand charges on their bills. This is legitimate engineering with measurable financial benefit in industrial contexts. But residential customers are not billed for reactive power. Your meter measures only real power consumption. Improving your home's power factor by plugging in a capacitor changes nothing about what the meter records. The small capacitors in these devices, typically rated between 5 and 20 microfarads, are far too small to meaningfully affect power factor even if it mattered for billing. To achieve significant power factor correction in a typical home would require capacitors rated in the tens of thousands of microfarads, physically large components that could not fit in a pocket-sized plug-in device. The products being sold are technically incapable of performing the function they claim, even in the incorrect context where that function would matter. They fail on multiple levels simultaneously. This has been documented exhaustively. Electrical engineering professors have purchased these devices, disassembled them, tested them with calibrated equipment, and published findings showing zero impact on energy consumption. Consumer protection agencies in multiple countries have issued warnings. YouTube channels dedicated to electronics teardowns have shown exactly what is inside, demonstrating that the components present cannot perform the advertised functions. Yet the products continue selling because new customers continually enter the market, see the claims, and purchase based on hope rather than technical understanding. By the time they realize the device did nothing, the return window has closed or the effort required to dispute the charge exceeds the product cost. The business model depends on exploiting information asymmetry and consumer optimism. But power factor correction boxes are not the only category of fraudulent energy-saving devices. Magnetic fuel savers for vehicles claim to align fuel molecules for more efficient combustion. They are magnets clamped to fuel lines. Fuel is not magnetic. Molecular alignment does not affect combustion efficiency. The devices do nothing. Radiator reflector panels promise to reduce heating costs by reflecting heat back into rooms instead of letting it escape through walls behind radiators. They are foil sheets placed behind radiators. The heat would enter the room anyway by convecting around the radiator. The foil changes nothing about total heat transfer. The devices provide zero measurable benefit. Thermal chimney caps claim to prevent heat loss through unused chimneys. They are inflatable bladders inserted into the flue, but the damper already present in every fireplace accomplishes the same function when closed. The product duplicates existing functionality at added cost without improvement. Window insulation film marketed as energy-saving thermal barriers claims to reduce heat loss by 70% when applied to single-pane windows. The film is thin plastic with no actual insulating properties. It reduces heat loss marginally through the same mechanism as any additional layer, but nowhere near claimed values. Actual testing shows 5 to 8% reduction under ideal conditions, not 70%. The marketing relies on consumers not understanding R values and heat transfer coefficients. Draft stoppers shaped like decorative animals and placed at door thresholds promise to eliminate cold air infiltration. They are fabric tubes filled with sand. They reduce airflow slightly but provide minimal benefit compared to proper weather stripping that costs the same or less and actually seals gaps effectively. The animal shapes are purely aesthetic, adding cost without function. Smart power strips marketed as energy savers claim to reduce phantom load by automatically cutting power to devices in standby mode. This is one of the few categories with legitimate function. Smart strips can reduce vampire power consumption, but they cost $30 to $60 while a basic power strip with a manual switch costs $8 and provides identical savings if you simply turn it off when devices are not in use. The automation is convenience, not necessity. You are paying $50 for a feature that saves perhaps $20 annually, resulting in payback periods exceeding 2 years for a convenience feature that a free behavioral change accomplishes equally well. The device works but is economically questionable compared to free alternatives. Attic radiant barriers sold as retrofit kits claim to reduce cooling costs by 50%. Radiant barriers are aluminum foil installed in attics to reflect heat. They work by reducing radiant heat transfer from hot roof decks into attic spaces. In hot climates, they provide measurable benefit, typically 10 to 15% cooling cost reduction, not 50%. But installation matters enormously. The foil must face an air gap to reflect radiation effectively. Foil laid directly on insulation or attic floors does nothing because radiant heat transfer requires line of sight across space. Many homeowners install barriers incorrectly, negating any potential benefit. Even correctly installed, savings rarely justify cost unless you are in extreme climates with significant attic heat loads. The devices work in principle but are oversold in magnitude and improperly installed in practice. Whole house electromagnetic field reducers claim to lower electricity consumption by neutralizing EMF interference that causes appliances to work harder. This is technologically nonsensical. EMF from household wiring does not cause increased appliance consumption. The devices contain basic circuitry that does nothing to affect power draw. They are complete frauds with zero basis in electrical engineering reality, yet they sell for $100 to $300 based on pseudoscientific marketing targeting consumers concerned about electromagnetic radiation health effects. The product exploits fear rather than promising savings, but the efficiency claim is included to broaden appeal. Programmable thermostats marketed with exaggerated savings claims promise to cut heating and cooling costs by 30%. Programmable thermostats absolutely can reduce energy costs, but the savings come from temperature setback during unoccupied hours, not from the device itself. A programmable thermostat set to maintain constant temperature provides zero savings over a manual thermostat. The savings potential is entirely behavioral. The device enables efficient behavior but does not create savings automatically. Marketing that implies the device itself generates savings without behavior change is misleading. You can achieve identical results with a manual thermostat and discipline to adjust it before leaving and sleeping. The programmable version costs $60 to $150. Behavioral change costs nothing. LED light bulb exaggerated lifespan claims are another category of misleading marketing. LED bulbs legitimately save energy compared to incandescent and last longer. But marketing claims of 25,000-hour lifespans or 25-year service life are based on laboratory conditions with ideal temperature, voltage, and duty cycles. Real-world residential use includes voltage fluctuations, high ambient temperatures in enclosed fixtures, and frequent on-off cycling that reduces lifespan significantly. Independent testing shows many LED bulbs fail between 5,000 and 10,000 hours, 20 to 40% of claimed lifespan. The bulbs still outperform incandescent significantly, but overstated durability claims lead to inflated cost-benefit calculations. A $12 LED bulb that lasts 7 years instead of 25 changes the economic value proposition substantially. Here's how you evaluate energy-saving device claims accurately. First, understand your baseline consumption. Check your utility bills for the last 12 months. Calculate average monthly kilowatt hours. Any device claiming to reduce consumption should produce measurable reduction visible on subsequent bills. If you cannot measure the impact at the meter level, the savings are negligible regardless of manufacturer claims. Second, research the technology independently. Search for the device name plus scam or debunked. Electrical engineers and consumer protection sites have likely tested and published findings if the product is fraudulent. Third, calculate payback period. Divide device cost by claimed annual savings. If payback exceeds 3 years, the device is economically questionable even if technically valid, because most products do not last long enough to justify the investment. Fourth, prioritize behavioral changes and free solutions before purchasing devices. Turn off lights when leaving rooms. Unplug chargers not in use. Lower water heater temperature to 120 degrees. Run dishwashers and laundry during off-peak hours. Use ceiling fans to reduce air conditioning load. These actions cost nothing and provide guaranteed savings. Devices that automate these behaviors are conveniences, not necessities. Fifth, focus spending on measures with proven high returns. Insulation improvements, air sealing, and weather stripping provide 15 to 30% energy reductions with payback periods under 3 years. LED bulbs and programmable thermostats work if used correctly with realistic expectations about savings magnitude. Sixth, ignore customer reviews on seller platforms. They are unreliable due to fraud, incentivization, and placebo effects where people believe they are saving because they purchased a product marketed as saving. Seek independent laboratory testing and third-party verification from entities without financial interest in product sales. Seventh, apply basic physics reasoning. Devices that claim to alter fundamental properties of electricity or thermodynamics are fraudulent. You cannot reduce energy consumption without reducing work performed or improving conversion efficiency. Small plug-in devices cannot change how your refrigerator or air conditioner operates. They cannot slow your meter. They cannot create energy from nothing or reduce consumption without trade-offs. The proliferation of fraudulent energy-saving devices is enabled by online marketplace structures that prioritize seller fees over product vetting, consumer optimism that exceeds technical knowledge, and regulatory agencies overwhelmed by product volume. The financial impact is not trivial. If 5 million households purchase $40 power saver devices that do nothing, $200 million transfers from consumers to fraudulent sellers. That money could fund actual efficiency improvements with real returns. Instead, it disappears into scams that persist because debunking reaches far fewer people than initial marketing. The knowledge exists. Engineering analysis is public. Warnings are published. But information does not distribute equally. Marketing budgets exceed education budgets. Fraudulent sellers outspend truth tellers. The result is persistent market presence of products that fail completely yet continue generating revenue year after year from new victims who never encounter the debunking information before purchase. If this just saved you $40 to $60 on a device that would have accomplished nothing, share it with someone tempted by ads promising 40% electricity savings from a plug-in box. Every person who avoids fraudulent purchases is one less victim subsidizing scams. Every dollar not spent on fake efficiency devices is available for real improvements with actual returns. The next analysis addresses legitimate efficiency upgrades ranked by true cost effectiveness, and what it reveals will change how you prioritize home improvements based on actual payback rather than marketing claims.